So in that case, let's get started then. First of all, I guess thank you everyone for joining us today. So I want to talk about, well, the topic says that don't try this at home, but really I want to talk about the value of experimentation and the need to do it tastefully, which is say that just because you could doesn't mean that you should, at least not when it comes to your production environment. But first, let's revisit one of the best films from the last decade, Inception, and customary spoiler alerts. Honestly, if you haven't seen this film already, make it the first thing you do after tonight's meetup. It's amazing. So the basic plot is that Leonardo DiCaprio and his team needs to infiltrate this guy's head in order to plant this idea deep into his subconscious, and to do that they need to go through this really complicated process of drugging him in the real world, and then go into his dreams, and then a dream within a dream, and then a dream within a dream within a dream, and so on, so on it goes. And right at the end, the film leaves us on this edge and questioning whether or not DiCaprio's character Cobb was living in a dream all along, and that he didn't actually reunite with his children, and it was all just a dream. Again, I'm doing the film a terrible justice here, but as you watch it for the fifth time, you start to notice a pattern that the Cobb, the protagonist of the story, and the DiCaprio's character, throughout the film, he was constantly telling people, don't do this, don't do that, and then he goes and does it himself. And when you consider the Dreyfus model for skill acquisition, where you start at the bottom as a novice and you just do what everyone else is doing, then you discover best practices and design patterns, and you gradually gain an understanding of how and why these things work, and over time you develop a sense of when to apply which pattern, for example. And then as you get even better, you start to mix and match different patterns together to compensate shortcomings of one pattern with another, and you also start to learn to deviate from these patterns as you need. But it still requires a lot of conscious effort and planning, but at least you know how to do it. And by the time you become an expert, you not only have the knowledge, but you also have the good looks to go with it as well for being an expert. Your hair is all sleek, you've got this nice suit and maybe a six-pack if that's your thing. But because now you have transcended the rules, the guidelines and maxims, because you have an intuitive grasp of the situations based on your deep understanding, and you can use an analytical approach in new and unfamiliar situations as well. That all sounds great, and that's all what we want for sure, I'm sure. But how do we go beyond scratching the surface, and how do we figure out that having a dream within a dream is actually a thing, or that limbos exist and all the rules that govern them? How does one find out about these things? It's not like they are documented anywhere, which incidentally, neither are the features in the Cognito service in AWS. Well, I can tell you what's not going to help you here. We're not going to become experts by just doing the same thing every day. Einstein defined insanity as doing the same thing and expecting a different result. The same theories apply here, that true expertise requires deliberate learning, which is also echoed by other theories on learning and expertise, including Malcolm Gladwell's book Outliers, which famously said that it takes 10,000 hours of deliberate practice to reach the top of an ultra-competitive field, which unfortunately is often misquoted and misrepresented. And I see crap like this all the time that confuses mastering your craft, that is being good or great at what you do, with reaching the top of an ultra competitive field. And it counts every hour of your working day towards the 10,000 hours, which is just not how it works. If all I do is kick a ball against the wall every day for 8 hours a day, I don't suddenly become Leonardo Messi or Ronaldo after 5.5 years. Because the 10,000 hours is for deliberate practice, practicing specific techniques, tricks, not just repeating what you do every single day. And just as deliberate practice is tiring, is deliberate learning should also be challenging as well. It should make you uncomfortable. It should challenge your fundamental beliefs of how things actually work, and it's often driven by your curiosity to peek behind the curtain to see how things actually work. I mean, how does one turn himself into a pickle? And Cobb did this by spending decades in limbo. So to become an expert, we need to go off the road and start walking into bushes and discovering new paths. That's how we gain deeper understanding of how things work. So my name is Yan Cui. I'm an AWS serverless hero, and I've been using AWS to build pretty scalable systems for more than 10 years now. And the last couple of years, I've pretty much focused on serverless, and including migrating a social network to run pretty much entirely on serverless with Lambda. Nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo is a troubleshooting platform for serverless applications that make it really easy for you to troubleshoot problems, even when you have this really complex and connected serverless architecture. The other half of my time I spend working as an independent consultant, where I work with companies all around the world and helping them adopt serverless successfully through training, advices, and sometimes helping teams build products as a hands-on contributor. In my free time, I like to produce a lot of content, from blog posts to video courses to books, and I publish a few with Manning. And this month, I'm also running a hands-on online workshop called Production Ready Serverless. We just started this week, so you can still join without missing out on any content. So in terms of the value of experimentation, provided that you share what you learn afterwards, it can create an immense amount of learning and value to both your organization and to the wider developer community as well. You can save your colleagues from making poor decisions based on incorrect assumptions and poor understanding of how some services work, and having to undo their mistakes months later and then re-architect things. But don't just throw your experimental code or POCs straight into production as they are. That's just asking for trouble. If it's done tastefully, experiments can be very valuable to everybody in and outside of your company. And they will be great for your career as well. If there's one career advice I can share with you, it will be to do experiments, blog about them, and speak about them at user groups and conferences. It's the same advice I gave to many of my colleagues at The Zone and beyond. For example, Simon, a good friend of mine now, built a very scalable WebSocket system for The Zone after trying out some of the services available in AWS and found their shortcomings for our use case. So he wrote about the experiment, he wrote about a service he built, and was invited to speak at multiple events about the whole journey. But don't stop there. There's always more for you to learn, and there's always more others can learn from you as well. And that's my talk. No, not really. You came here expecting some serverless stuff. So here are a few experiments I've collected that I find really interesting about Lambda. For example, did you know that you can run headless Chrome in Lambda, which started off as an experiment and it was kind of clumsy to do, and then came a serverless framework plugin that makes it actually quite easy. And when you think about it, there are actually lots of legit use cases for this, like scraping web pages or generating web assets dynamically. For example, one of my clients generates these hand-drawn animations that you often see on YouTube, and they do it through headless Chrome running in Lambda. And increasingly, I'm also seeing people doing end-to-end testing for front-end web pages and even visual testing as well, all driven and ran inside a Lambda function. And for anyone who's constantly reminding you that there's still a server behind the Lambda, which is A, besides the point, but also B, the opposite can also be true, because guess what? You can also run a server inside a Lambda function, so you can have a server running inside a function, running inside a Lambda, running inside a function. Server. See, it gets confusing there. And as pointless it may seem at first, it's actually quite popular with researchers and have been used in several that I know of, machine learning and deep learning research projects at universities. Someone even open sourced the tooling that they use for that as well, which I thought was quite interesting. And then there's this guy called Tom Wallace, who is always talking about applying metaprogramming techniques to Lambda. And metaprogramming is basically when you write programs that write themselves. For example, when you look at Lambda function, a function can have access to its own code. It can deploy updates to its code and configurations like memory, timeout, etc. And it can even update its own event source mappings to change the batch size from kinesis or other similar configurations you find there. So a function can actually self-optimize on the fly by, say, adjusting its memory and timeout dynamically to deal with back pressure without having to require some human operator to do an update. And it can also deploy updates to itself. Tom, for example, had a use case where he needs access to ultra low latency cache, and the cache is kind of bulky, but only changes once per day. So you can either load this big blob on every single cold start, which adds the execution time, or he just bakes a cached value into the code and has the function redeploy itself once per day. It's not something that I recommend for pretty much anyone, but for his specific use case, it was actually an ingenious and efficient solution. Other examples also including using having those static, slow changing values that you may find in environment variables and being able to dynamically change them as well. And for the more sort of outlandish ideas, you may also can think about, well, can we in that case auto-generate API endpoints for those multi-tenant SaaS systems, or more practical ideas like we can have functions that can self-optimize or self-heal. For instance, I worked on a client project where we built a self-healing kinesis function that adjusts its batch size based on the latency and error rate from the downstream system. And we even had the built-in circuit breaker to stop the kinesis trigger altogether. And then every 10 minutes, we're going to re-enable it and at a batch size of 1 to see if the downstream has to recover from whatever error it was having. This was necessary because the downstream system is this third-party banking system that would blacklist us if we ever access the APIs too aggressively. And being blacklisted in this case is basically game over for the business. So metaprogramming is very clever, but there are some obvious dangers involved here. First of all, it's just so much more complexity. I mean, having code that writes itself, good luck with that. And by design, their behavior is also mutable. So how do you even write tests for that? And now functions can update themselves, which is bound to alert any security people you have in your organization. And by the way, forget about having immutable infrastructures because the functions are just going to update themselves. And if that's not enough, turns out you can also just SSH into your Lambda function. Of course, that's not a thing out of the box and requires some pretty clever back tunneling from a Lambda function to connect to a SSH server that you run locally and expose publicly through ngrok. But where there's a will, there's a way, right? And just for fun, some folks, and to see how Lambda is actually really secure, some guys at lambdashell.com posted a bounty on to challenge anyone to do damage to a function that you can access through SSH tunnel. The funny thing is, the Lambda function was fine, despite the whole SSH shell being exposed, but they left the S3 deployment bucket public. So someone hijacked the site and took them down. So the moral of the story here is that when it comes to security, don't just look at your functions, look at the whole thing holistically. Right, so continuing on, a girl from Epsilon did some really interesting reverse engineering of the Lambda execution environment and found that there's this bunch of native methods that you can, or libraries that you can bind to and then run from your function that will essentially mark the current invocation as having completed and then start a new invocation. And while you still pay for that new invocation, it means that you can sidestep the whole 15 minutes invocation limit. And so if you have a long running process, you can do this in one invocation from the perspective of your code, but without having to use tricks like writing recursive functions. But I stress again here that you do still pay for them as separate invocations. Again, some pretty obvious danger signs here that since you're relying on implementation details that can change without notice, so if you're actually going to do this, then know that one day you would just stop working when the Lambda team makes a change to the environment. And here's another fun one. For anyone who wants to step through the code that is running inside a Lambda function live, which involves running basically a proxy library that passes debugging instructions back and forth between your machine and the code that's running inside the Lambda execution environment, which understandably means that the invocation is just going to hang while you step through the code one line at a time. This is again very, very clever, very cool idea, but there are some much easier way to debug code. For example, using the SAM and the serverless framework, they let you invoke functions locally. And you can attach a debugger there. They don't let you run against a live function, of course, but you can only do that in a very controlled environment anyway, where you need to really up your timeouts to give yourself time to step through the code, and there's no one else using the system at the same time. SAM and the server framework can use the Docker Lambda project to give you a Docker image that basically matches the actual Lambda function runtime. So you can already execute and step through your code locally while running them in the AWS-like environment. And along the sort of whole Lambda as a server ideas, turns out you can also run a TCP IP stack on Lambda. By taking advantage of the fact that Lambda connects to the CloudWatch log streams through TCP IP, and you can change that network endpoint to your host. But as you can see, it's really, really slow. So really, there's not much practical application here. That is not that I can think of. But it's open source, so feel free to check it out if you want. So those are some of the fun, but maybe not so practical experiments I've seen. They do expose many of the underlying implementations details of Lambda, and we can learn an awful lot about the platform through them. There are also many other experiments that have yielded practical actions that help us improve the performance of our code. For example, I did a bunch of experiments with a client of mine. I measured the code start for Lambda functions by looking at the setup time, which you can roughly think of as the time that Lambda takes to find a space in the fleet of EC2 instances to allocate a container to run your code before you can even run initialization on your module, and which together is basically what we would call as consider as the code start time for your function. And it turns out that initialization is always performed at maximum CPU. So memory actually has no measurable impact here. And we kind of omitted it from the graph here. And also, more importantly, B, more memory means taking longer to allocate the container. Presumably because, you've got a fleet of EC2 instances, so someone asking for 3 gig of memory, it's going to be harder for you to find a gap in the resources that fits that 3 gig in. What that means is that overall, your code start is probably going to take longer if most of it goes towards the setup time. Of course, it's also worth mentioning that the whole experiment was done quite a while back. It was over 12 months ago, so these numbers are likely quite different now. And if you want to optimize the performance of a function, you need to measure against realistic workloads. It could be that you're also doing more CPU intensive work. So even if setup time is longer, there's just significant saving in the warm execution time. So you still want to use high CPU setting regardless. And you can't really talk about memory optimization without talking about Alex Casaboni's power tuning Lambda tool, which nowadays you can also just run as part of a CI/CD pipeline, which I've got a blog post to show you how to do that to make sure that you're always running on the most optimal memory setting for your workload. And while we're here, have you wondered how expensive using the AWS CK is and how much code start time it adds? Because remember, during cold start, Lambda needs to initialize your module and require your dependencies. And turns out, when you require the full AWS SDK, it adds over 100 milliseconds to your cold start time for Node.js functions compared to when you require only the DynamoDB client, assuming that that's the only client you need. And if you use Webpack for Node.js functions, that is, then you can also even improve your cold start time even more, because most of the time in the initialization phase of cold start is file system calls to load all those modules. So Webpack collapse everything into one big module for the function, and hence eliminating any and all those file system calls and making your cold start go faster. And the last experiment I want to share is the fact that HTTP Keep Alive is not enabled by default for Node.js functions. And through an experiment, I found out that if you just set this environment variable to 1, then you literally save yourself about 20 to 25 milliseconds for every single AWS CK operation. So talk about the simplest optimization you can do ever. And this applies to cold starts as well as to warm starts. So those are just some of the sort of things I learned through experimentation with Lambda and AWS. The great thing is that all of this pretty much didn't cost me anything, because running experiments on the cloud is just so cheap, especially when it comes to serverless, because you only pay for what you use. And we have come up with so many useful ways to improve the way we build serverless applications, because we've been doing all these different experiments. And they also help us gain a much deeper understanding of how the Lambda platform works, and helps propel us towards up the ladder towards becoming experts. So remember, you want to do these experiments very tastefully. So do it at home. Maybe don't do them at work. At least not throw your experimental code or POCs straight into production. And remember that learning itself can often be its own reward, and sometimes probably the only reward that you should be looking for. So that really is the end of my talk, and here's a list of links to the experiments I mentioned in this talk, so feel free to check it out afterwards. And as I mentioned earlier, I spent most of my time as an independent consultant, so if you want to see how serverless can help you and your organization go faster, or need some help just upskilling your team, then let me know. Go to theburningmonk.com/hire me to see how we can work together. And I'm also running some public workshops this year, so that's going to teach you everything you need to learn, need to know to build production-ready serverless applications. And I'm actually running one instance of it right now as an online workshop, and you can get 15% off with this code. And you can also get 20% off my video courses with this code as well. And so with that, thank you guys so much for your time, and stay safe, everyone.